name is Henrik, like I said. I'm a cloud-native advocate at Dynatrace, and I'm pretty much focused on the topics I just mentioned, so Kubernetes, OpenTelemetry, Observability in general. Prior to that, I spent my whole career on performance engineering, so I love performance. That's why performance is still in my heart, even if I'm touching more observability topics. And that's why I'm one of the producers with Mark and Alejandro on Perfbytes. And 1 year ago, and a half, I would say, less than a half, I started a YouTube channel called Is It Observable? So I'll make a teaser at the end, of course. You'll have to watch it, you have to subscribe, you have to give me some feedback so I can improve the content. So check it out, it's out there, it's made for helping people to get started, so it's free material, so yes, feel free to use it. So what are we going to talk about in the next 28 minutes, exactly? So first, we're going to do a gentle reminder on the Opentelemtry project in general. So there are various components involved in the project. So we're going to touch base on this. We'll see that if you want to start instrumenting, we're not going to do any code for sure. I'm just going to remind you objects that are meaningful, that you understand those. So then once you have going to touch base on those, you will understand what those objects mean for you. Then, of course, we'll see that we are giving the hands of observability back to the user, to developers. So it means that the potential is going to produce metrics, logs from our code directly. And we will see that we need at least to check a few concepts about quality of the observability in general. And of course, we'll see how we can improve ourselves. What's the best way of getting started? All right, are you ready? All right. All right, so once upon a time, I don't know, we're going to go back in the past, a couple of years back, and at that time, people were calling it mainly monitoring. I'm pretty sure that you're familiar with that term. And at that time, there was a couple of vendors that were providing solutions that helping you to observe and understand what's going on actually in your environment. Obviously, to do that, as a reminder, we will deploy agents. And those agents were basically getting on the host's level, CPU, memory, disk, whatever. And also, we were able to produce traces out of the application. So that was wonderful. At that time, we were pretty much in a control environment. So a physical server sitting in a closed environment. So basically, we're controlling the environment so we can deploy those agents without having the need to deploy or remove them and redeploy again. So at the end, with this quality of data, we were able to report lots of meaningful information. We were super happy. And one of the features that was there is about instrumenting and profiling our code. And the market was a bit inconsistent. There were vendors like Dynatrace that were doing everything automatically. So you were just shipping the agents and boom, by magic, everything was instrumented. And there was other solution where, well, you had to precise what you want to see. But as in general, if you were enabling profiling, I don't know if you've been doing testing with profiling enable, you had that situation where you try to use the application, but it's barely unusable because the profiling is like stuck in the thread, and then you're stuck and you're not unable to use it. Well, this is over. You will see there's great news. We can do profiling now. Then all the things that change is that the fact that our IT environment has changed. Instead of being in an on-premise environment, very closed environment, we moved our workload to the cloud, and those workloads are ephemeral. So you can spin a pod or a node, and this node will disappear in a few minutes, potentially. So the challenge of monitoring has obviously changed. And the other also aspect is that methodology in general has changed. We are not doing Waterfall or whatever. We're doing more modern approach, and we need observability to improve. So we need something to help us. So the market is in danger. We need to find the right solution. And the solution for this was moving from monitoring to observability. But what is observability? Observability, to just remind, it relies on various pillars, various signals that will help you to fully understand a situation. You're not seeing something and you have to dig down, deep dive in, understand a situation. You have the information, you understand. And to be able to understand, you need logs. We have logs on our code, that's great. Events, so we have environment like Kubernetes that throw events everywhere. But also, in your CI/CD pipelines, you also have events like I'm deploying, I'm testing, I'm doing a release. This is events, useful information that help you to bring context. Metrics, we know, but metrics, we have now dimensions on top of our metrics. traces. Traces is a concept introduced a few years back. But usually when you diagnose or you troubleshoot a situation in production, you look at the traces, you see that there's a step that is slow, but you want to jump down to profiling. You want to see what's actually the origin of the problem. And of course, the exception. So the great news, if you look at, if I'm starting in the observability world, I will go to CNCF, so Cloud Native Computing Foundation, and I see, oh, there's a bunch of solutions, free vendor, that's great. This is not really what you will get from the CNCF website. You will get this. And at the end, there's thousands of different solutions everywhere. You try to figure out which solution you're going to pick. Good news, I'm going to help you to find which solution you have to use. So first, OpenTelemetry. This is the reason I'm talking. We're going to jump very deep on this one. It's a standard. So everything which is on the right side for you, no, left side for you, it's the standard. So OpenMetrics and OpenTelemetry is a standard. On the right side is the tooling. So there are toolings for logs, for diff and bit. There's tooling for metrics, you know them. And there is also Grafana, which is for more visualization aspects. So now you have the layer. So let's jump in OpenTelemetry, our topic. So OpenTelemetry is a standard. So at the end, we have the ability today to include libraries, and we will produce measurements, metrics, traces, and more in a standard format. So which means the future is we don't need agents. I don't need to use a vendor like Dynatrace or New Relic or Datadog and use their agent anymore. I can rely on a vendor agnostic approach where I produce my signals and I send the data back to the vendor. So in OpenTelemetry, there are two main components very important. There is the instrument. So you build signals out of the code. So you have music coming out of the code. And then to be able to get the music properly propagated in the audience, you need an amplifier, and the collector will be amplifier. So with the amplifier, you can put some effects, you can modify the sound, you modify the signals, and you can also amplify to send it to, I don't know, Dynatrace and Kafka. You have the options to send to several sources. Currently, the project, which is open source, by the way, it's a second CNCF project. Do you know which is the biggest CNCF project? Don't be shy. Right, it's Kubernetes. Just after Kubernetes is OpenTelemetry. So you know how much the adoption of Kubernetes is currently in the market. So you can realize that this is going to happen very quickly on the market. So you should be aware of it. So in OpenTelemetry, there is various pillars of observability that is covered. So traces is there since 2 years now. It's stable. You can rely on it. You can use it. That's feel free to use it. Metrics is mainly stable in most of the language, I would say. There's few language which is still in alpha release. Logs is going to be available in next year, beginning of next year. And continuous profiling, the specification is on the way. We should have it probably end of next year or beginning of next year. So how do you produce measurement? For this, you need obviously a couple of things. So for this, we need to inject an SDK in our code. So there's the manual approach where I have the library, and from the code perspective, similar to logging, I will decide what I want to produce in terms of metrics or traces. But you usually don't start with the manual approach. You have the automatic approach where you're going to load the application, and when the application is loaded, we attach an agent. And that agent will instrument well-known framework. So today we use different framework in different language, so Spring, Java, or Express, or Flask. I mean, there is plenty of different framework on different language. So those will basically instrument those frameworks. They're not going to instrument by surprise your code if you don't use a framework. So if you don't have any framework in your code, you will have to go manual. Then if you do the instrumentation, there are a few objects important. So you have the OpenTelemetry API SDK that holds everything. And then inside of that, you'll have a trace provider that will need to be defined. And there are a couple of settings required. So the span processor will explain what it is in a few seconds. The sampler, the exporter, so where I want to send the data, and the resource. The resource is like the identity of the service. And you have the propagator side of it. So the span processor is a critical element because it will determine how the communication will happen. So two types of span processors available. One is simple span processor. Every time I end something, I will send it. So basically, it grades because it's going to be live telemetry data. So if you want fishing for live instrumentation, live information, that's great. Second one is batch span processor. As you can understand, if you do live, lots of communication going on, lots of network consumed, so maybe it's not optimized. So batch span processor is the most recommended one, where you're going to push, publish measurements. They will be pushed in a batch, and that batch will be sent every X second. So less live data, but at least you have the data. The other one is sampler. So sampler is a concept of deciding what I want to drop and what I want to send to the observability backend. If you use vendor today, Dynatrace, we are controlling our agents, so we decide how much data we need to help you to troubleshoot. In Opentelemtry, it's not the case yet. So you have to define it manually. So there are a couple of samplings. So we have always on, where 100% of whatever you produce will be sent. Usually it's great, but it's very expensive. The other one is like, no, I want nothing, always off. Parent base is great for dependencies. So here, for example, service B is called by service A, so it's going to be a child. So I will configure it as a parent. So I will only send details once I'm being involved in a transaction. Trace ID ratio, I define a ratio, a percentage of trace or metrics I want to push. Very simple. And last, you have a combination of parent base and the others, so I'm not going to describe everything. But what's important, depending on what you define in terms of sampling, you can have less or more detail. So here, example, I have some couple of ratios, so 50% of service A, service B 25, and so on. So if I want to have a pure end-to-end trace from A to E, and I have 1,000 requests coming in the systems, if I do the math, I only have one trace, which is quite low. So you see that the sampling is very important because it will determine how much details I will have back when I need it to troubleshoot. The other concept is trace propagation. Trace propagation is, you should not be worried, but something really important is that when you build a trace, if I start a trace from a service I know the context is my code, so I can pass the context to the various methods that are being instrumented, but then suddenly I call the service B. So how can I make sure that the context is being sent over, so down the trace continue to the backend? Well, this is where propagation happens, where before the service A is calling the service B, it injects the context, and then the service B, when it gets the call, it extracts the context, so then the traces continue in your environment. Why I'm telling you that? Because there are different trace propagators in the market. So basically, if you don't speak the same language, then you're losing the details. So there is B3, which is open tracing, and there is the rest, which is OpenTelemetry. W3C is all the OpenTelemetry. So if I have an OpenTelemetry and B3 on the same environment, then I'm not talking the same language. So I won't have that detail. I'm missing the detail. So there are a couple of components like Ingress or Service Mesh. They are using B3. So if you use OpenTelemetry and Ingress, you won't have much detail. They are working on improving it. On the metric side, I'm not going to do too much on this. You have a meter provider, so it's going to be the main object that will define how you're going to build metrics, and you will define meters. Meters will be a name, a description, a unit, a metric. And then inside of that, you have an instrument. Instrument will have a type. It could be a counter, a gauge, histograms, similar to Prometheus. And this is where you're going to add the values. And similar, once you produce a metric, you need to send it somewhere else to use an exporter to do that. There is a concept in OpenTelemetry which is fabulous. It's called exemplars. So imagine, I'm producing some trace in my code. They are in the same context. And I have a trace ID, a context related to my trace. And suddenly I build a metrics. And then I build some logs. If you do so, then every single signal are attached. So I'm doing some troubleshooting. I'm looking at trace. Oh, it's slowed down. I want to look at the CPU profile of that user. Boom. I can do that. I can filter the CPU usage of that particular user. This is the notion of exemplar. So this is very powerful. Again, things will be improving in the future, but this is a great way. One of the components that is crucial, I barely mentioning it, it's the collector, the amplifier. You will see that the collector is a critical component, and you will have to manage it in the future. So you can deploy the collector in various ways, agents, so it can be sitting close to your code, so very optimized because only localhost communication to push your telemetry data. You have the host, so it's more in Kubernetes. You will deploy it at every node of your Kubernetes cluster. And last, you have the gateway, which is a big bang service that receives everything. This is not recommended. So if you're using maybe an old technology, maybe you have to use this, but this is not going to be recommended. When you use collector, usually you not use one collector. Most of the customers today, they have thousands of collectors that they have to manage. So usually you split the processing work of your traces and metrics on several components. One locally, so here I have the red components that will be a collector sitting in a sidecar. I do some pre-local processing, and then I send back to another collector that will do an extra processing, and then I send it to my backend. And the great thing here, if I do that type of design, if I need to switch tool, I use Datadog and I want to switch to Dynatrace, obviously, I would have to just change one spot, the green boxes, and that's it. So less maintenance at the end for the users. The collector is similar to a log agent processor, FluentD, FluentBit, I don't know, Logstash, maybe you know those. When you do use those products, you have to build a log pipeline. Here it's the same thing, you have a pipeline. So this is the language for on the right side, where you receive some information, you process, you drop, you modify the data, and then you export the data somewhere. Side of that, you have extensions. Extension is a way of increasing features on the collector level. The color is different here in that slide because the extensions has never access to the data. It's something that is never access to the metrics, to the traces, so it's a bit specific component. So now you have in mind most of the main components, but you see that when you build telemetry at the end, keep in mind you use it for automation, for DevOps processes, but also when you are facing a big outage in production. So the quality of data that you produce is very important. If I have a metric, that metric I need to be able to split it by server. Let's say I have a CPU. If I have the average CPU of my environment and I have thousands of servers, I won't be able to understand where this CPU is being consumed. So I need to be able to split by server, by zone in the cloud, so the notion of dimension is very, very important. Bring the extra context. Traces is the same thing. If I don't instrument well, maybe I have some gaps and I don't know where I'm spending time. So I need to have efficient and good visibility on the details of a given transaction. You also have the notion of events. When I build a trace, I can send events. Events are very important. So say I'm doing a paying transaction where first I need to reach out to the paying platform, then it's been acknowledged, then I can go further. So there are several steps in my transaction, and so I can create events. And events are very powerful, similar when you have to troubleshoot. And last, signal is logs. You know that if you produce logs and there is no context, you have just a text line, which is very hard to utilize. Adding context to the logs is very, very important. Because at the end, when we have that telemetry data, we are going to potentially have a murder. Our server will be down, killed by a bad user or a bad bug. So we will have to profile. We will have to investigate. And so if you don't have the context, you're not able to connect the dots. The tracing challenge today is related to the fact that we have two personas. We have on one side, we have the producers. And on the second side, we have the consumers, the one that will deal with data. And the problem is that the producer usually have different objectives when you use telemetry data. If I use telemetry data in my dev environment, I'm fishing for live data. So to do live debugging, for example. So I'll probably use simple span processors. And I want to have 100% of my traces. So we'll use always on. And the other thing is sometimes you're looking at your service, you have not a good broader vision on the entire environment. So you do things related to your small context, so you don't necessarily add the right context sometimes. So that it happens. And the other thing, when you do tracing, let's say I'm producing a tracing, I did some auto instrumentation, I'm so proud, I see in the UI, I got my detail. And then you try to troubleshoot, and then you see, oh, we're spending time on that blue bar. Okay, what is it? Well, I think it's not well instrumented. So if you re-instrument it, now at least I have more detail. So for example, checking that the details that you're getting is efficient and meaningful is important, because otherwise you won't be able to be efficient when you have to use that data. The other persona is the consumer. The consumer is obviously looking for having data, enough data, but not paying too much. Sorry. Because if you, let's say, send 100%, of course we're going to deal with data, but the building and the licensing that you will have to manage is going to be very expensive. Imagine it's going to be 1 terabyte per minute of data per metrics, then 1 terabyte per minute on traces. So if you can manage by yourself in storage, no way, no problem. But keep in mind it's going to be very, very, very expensive. So you need to figure out what level of details I need for the right cost. Then, because I'm dealing with thousands of teams, I need to write dashboards with providing the right information that will for everyone. I don't want to have a building dashboards for every single team. It doesn't make sense. I have more interesting things to do in my day-to-day job. So I need to adjust the instrumentation. So I need to be in contact with the right people. I need to make sure that we have the right context. And also I need to be able to build alerting on those components. So how can you continuously improve tracing? Usually you start simple, and then you continuously improve. So the first reaction is that most of the network components, so ingress, service mesh, if they're using W3C context, they are producing traces. So if I enable the service mesh, all the services that go through service mesh, I will have traces. So I can see all the communication requests going back and forth. So at least I have this network map. So that's a good start. At least if I know that I'm spending time in one component, I will be aware of that. Then, to add more details, I can enable automatic instrumentation. So then I know I'm going in a given service, and then I have all the traces generated by the framework. So I have extra details. And last, if I'm missing something crucial on a given business component, yeah, I don't rely on a vendor library. So I can jump into the code, ask the developer to instrument, and I will have the detail that I need. Same thing for metrics. You have the luxury now to say, hey, I want to create a business metrics of my payment service to track some meaningful information for my company. It's agnostic. You can do that now. One thing which is unclear is the which is unclear is the tracing cover. Today, we instrument, but we have no clue on how much detail we have, how much services is being covered. So there is this notion of tracing coverage. We don't have it. Something similar to testing coverage. This is something we should track in the future. There's no standard, but we can imagine to have a rule saying, okay, so I'm going to count all the requests that are in my environment that have the W3 tracing context. If there's a tracing context, then it means there is some tracing. And then I divide it by the total number of requests I have. So at least I will have a ratio. So technically, it works, but keep in mind, sampling goes in the picture. If I have the sampling happening where telemetry data has been dropped, then there is no trace ID. So I don't know if it's a non-instrumented service or if it's a service that has been just sampled at that moment. So again, there is no recommendation as of now, but I think with the community, it's open source. We can basically, everyone can contribute here in this room, find some way of improving, find a way of helping to testing those type of observability. So there's a lot of things that it's still needed for the big organization to utilize it heavily. So we have to work on together. So the takeaway. So first, make sure that in the future that your code is agnostic, that your environment are agnostic. Don't rely on vendor library because you're going to be locked to that vendor. So by having open source or an agnostic library, at least, you are free to move on without any effort. Observability, of course, producing tracing, metrics, events, everything that can help you to troubleshoot and be more efficient in your day-to-day work is important. So putting observability everywhere, it's recommended. And then continuous, like I say, start being smart. Don't instrument manually directly. Do the automated. Use what could be produced in a very efficient way, and then add last mile in manual if needed. And if you're starting from scratch, a new application, you just have to need and ask the developers, you're producing logs, why don't you produce traces and metrics as well? So it's easier when you build a fresh new app. So there is plenty of other content I can talk about, but I am almost at the end of my talk. So I will recommend everyone to check out my YouTube channel, to subscribe to the channel, to watch the content, to send me some feedback so I can improve the content. There is plenty of content related to Opentelemtry, to logging, ingest, blah, blah, blah. So check it out. It's free. It's out there. And the idea is that for any open source product, if the adoption is here, then it's a success. So let's make this project a successful product.
Now, we have a few minutes for questions. So I don't know if anyone wants to volunteer with the first question. There we have one.
Hi. So are there any plans for implementing conditional sampling? Like being able to, when some condition is met, then sample that request?
It's a great question, to be honest. So there is a specification on the way from the Opentelemtry called OPAMP. OPAMP is a way of managing OpenTelemetry fleets. So what is an OpenTelemetry fleet? In fact, it's not OpenTelemetry fleets, it's agents. They help to manage agents. So OpenTelemetry collectors are agents. Because there is a pipeline, I need to upgrade and maintain that. There is the SDKs. I want to switch the sampling decisions lively. There is also FluentBit, all the log agents. So there's plenty of components that we manage on day-to-day basis, and this protocol is aimed to basically all the agents, all the collector will run, spin up, connect to a server, and the server will be able to maintain it. So get telemetry data, the health, but also update the setting. So if I want to lively change my sampling decisions based on events in the future, with that protocol, we can imagine, so Dynatrace is working on that. In the future, it means that Dynatrace will be able to control those telemetry agents and say, hey, now I want to have more detail. Or no, it's fine, you can do it. It's sampling, giving the complex problem of sampling to the hands of the user doesn't make sense. All the solution vendors have been working to improve it from a smart way. So I think this is the future.
Anyone else? We have time for another question. There we go. Yeah.
Based on what you mentioned and the examples you gave, it makes me feel that everything is prepared for Kubernetes, but it should be available also if you are not running on Kubernetes, right?
No, it's designed for everything. It's just the way you can deploy it. It's make your life easier in Kubernetes for sure, but you can use it on any technology. It's not sit to the technology. And also, if you use Lambda functions or serverless architectures, today there are a couple of observability solutions like Agile. We can inject our agents before it starts the functions, but sometimes it's not possible. So here, I say, why don't we use Opentelemtry for these things? And then I will have telemetry data out of those serverless or functions.
Thank you.